Hi there. This lesson is called Mean Absolute Deviation. It is lesson 11.4. We are going to be learning about this different way to describe the variation of data. Just like IQR, mean absolute deviation is a different way to describe the spread. So you're going to need the white note paper that you had passed out to you in class and the purple one. We're going to start taking notes on the white one here. So the first thing we're doing is, what does MAD stand for? It is the mean absolute deviation. So go ahead and fill in the M for mean. That's the average, not new. The A stands for absolute. We're going to be dealing with absolute value as it pertains to distance. And the newest word, deviation. So, mean absolute deviation, topic of today. What does it mean to deviate? Like my fish here, it means to go away from. So if I'm walking in a line, and I'm trying to stay on that line, and I step off of the line, I have deviated away from what I was supposed to be walking on. So just a little bit of background to help you understand what deviate means. To go away from something. You deviate from the crowd. In your notebook, I know in the last video I showed you the table of contents and you probably couldn't see it, so it should look like this now. We should have page 74 and 75 will be our mean absolute deviation. You don't have to glue in things yet. We can write and fill them out and then glue them in later. So, continuing on that white sheet, what is the definition of a mean absolute deviation? It is the average distance between each data value and the mean. How do you find the MAD? There are 3 steps. And for these steps, you don't have to write anything. It's literally the first 3 steps on your purple page. So I'm just going to walk through them. We're going to first find the mean of the data set. And then we're going to find differences. That's where the absolute value comes in. We're going to be doing some subtraction for each data value and the mean. And I'll show you what I mean. Then we're going to take those answers that once we subtract and find the mean of the distances. And so I have an example that we're going to do inside. So if you take your purple paper and you have the steps on the front, if you fold it, we're then going to do 2 examples, one on this side and one on this side. And we're going to be dealing with 2 basketball teams, Allie's and Lena's. And the first one that we're going to do is Allie's team. So this is going to be on the left side of our notebook. And we're going to follow those 3 steps to find the mean absolute deviation of these numbers. So I just have these numbers here for us to refer to. For Allie's, we are actually going to first find the mean. That's the first step. So we are going to add up all of those numbers. So 48. I'm also going to be, it doesn't matter if they're in order, but I'm going to put them in order just so that we have them more organized. Plus 52, plus 54, plus 60. 58, 58, 60, and 62. There are 8 numbers. When you add all that up, it will equal 440. And when we divide by 8, we will get a mean of 55. That's step 1. Just find the mean. We did that before. So I'm going to draw a little squiggly line. Now we're going to do step 2. For this example, I'm actually going to display the data points on a number line. This is one way to do it. So I'm going to draw a number line, and make sure you have it the entire length of your notebook half of paper. And we're just going to start at 48, and I'm going to go by twos, because that seems to be the pattern here. I'm having a tally mark to mark off the odd ones as well. Whoops. And you don't have to do this all the time, but I want to show you, especially with this first one, what it actually means to deviate away from the mean. So we're going to just draw a dot on each data point so that we can see this a little bit clearer. What you have to do is find out the distance each data point is away from the mean. So if the mean is here at 55, I'm going to draw a star at 55. Here's the mean. I'm going to pick a different color here so you can see it better. We are going to actually figure out the difference between 55 and 56. So that's 1 away. There's 1 away here. And now we're going to find the difference between 58 and 55. That's 3. I'm going to keep going in this direction. 55 and 60, what's the difference between that? Is 5. And then the last one, 62, is the difference of 7. So literally I'm finding the absolute value, the distance, but my 0 is actually the mean. I know absolute value always is distance away from 0. We're finding the distance these data points are away from the mean. So now we're going to do the same thing on the opposite side. We started with the 54, that's 1 away. This one happens to be also 3 away from 55. And 55 minus 50 is 5. And then the farthest one out is 7 away. So now we have 8 new numbers. They are pink or red in my example. So we have 7, 5, 3, 1, 1, 3, 5, 7. The last step, and I know I'm running out of a little bit of room here. Hopefully you have a little bit of room underneath. We're going to take these new numbers, add them up, and divide by 8 to get our MAD. So I'm just going to erase my original mean so that you can still see this picture. So this is my step 3, is to take the 7, the 5, the 3, and the 1, and then the 1, the 3, the 5, and the 7. We're going to add all of those up. When we do, it actually equals 32. And we're still dealing with 8 numbers. So our MAD, our mean absolute deviation, is 4. And that is going to represent something. We're going to talk about that in a second. So that's our first example. Now we're going to do a slightly different way of doing it, not with a number line. Instead, we're just going to do a column. So on the right side, we're going to talk about Lena's basketball team scores. So Lena's team has 8 numbers as well. So the first thing, same, we're going to, and I'm going to use this space up here, hopefully I'll not run out of room this time, to find the mean. So when you add up those numbers, let's use my cheat sheet here, we will, and I'm going to put them in order. Here are all of those numbers in order. When we add these up, ironically, we will still get 440, which will allow us to have the same exact mean as the other basketball team. So our mean is still 55, but we have different scores for Lena's team. Instead of doing a number line, another thing you can do to find the difference of each data set is to put them in one big column. So I'm going to do that for step 2, 48, all the way down. Now I did that so that I can now subtract. Now the mean is 55. So 55 for these first four is higher. So I'm going to have to take my 55 and subtract over on the left so that I get a positive number. $55 minus 51, that's 4. We have 5, we have 6, and we have 7. So that is the distance away each data point, which is black, is away from 55. For the last four, they're all higher than the mean, so we're going to just subtract on the opposite side. Subtract 55, and finding the difference that each data point is away from 55. And we will have the same numbers, 4, 5, 6, and 7. So now these numbers right here and right here, the differences, the third step, we're going to take those, add them up, divide by 8 to find the mean of these. So I do have room, yay. We're going to add these 4, and then the second group. When you add all of these up, it does equal 44. Doesn't work out as nicely. So 44 divided by 8 is actually going to equal 5.5 for Lena's MAD, mean absolute deviation. So now that we've done 2 examples of finding the mean absolute deviation, or MAD, now we're going to talk about what does this actually represent. You're going to be asked in class tomorrow, describe what this represents. The answer to that question is the MAD is the average distance each data value is from the mean. So when you are asked to describe what the MAD represents in a sentence, your note sheet has a boxed in answer. It's almost like a scripted response. This will work with any example, really. This is what you could say to answer that question. The MAD is, and then whatever it is. For Allie, it was 4. So that MAD was 4, and we're talking about basketball points. So one thing that you can say is the MAD is 4. That's what we did when we found all those steps. This means that the average distance each data value is from the mean is 4, and then we're going to always put a context. Context meaning the subject or the units. If it's miles per hour, we would say 4 miles per hour. We do want to add that points is our unit for this example. If we were talking about Lena, we would say the MAD is 5.5. This means that the average distance each data value is from the mean is 5.5 points. Now visually, I'm going to show you what that means with both Lena and Allie in a minute. You're also going to be asked to compare too. That's why I gave you that first problem with the 2 teams and their basketball points. Sometimes we're going to have 2 sets of data, and we're going to be asked to write a few sentences comparing the 2. And tell us about the variation differences between the 2 data sets. The MAD, these are some tips that you can write down along with me on your white sheet. One thing that you could say is using those words less or greater. So you could say that the MAD of one of them, say Allie's, is less than the other one, which is Lena's. So 4 is less than 5.5, so that's one thing you could say. You could say the flip. You could say that Lena's is greater. Fill that in. You could say Lena's spread is greater than Allie's. One other way that you could write about the 2 is that you could say that the data of 1 is closer together. If, in general, the MAD is smaller, that means the data values are going to be closer together and closer to the mean. Another tip, another way you could compare is if the MAD is larger, you could say that the data of, in this case, our example would be for Lena, because 5.5 was the larger MAD, that would be data that would be farther apart. Another way to think about it is that it's farther away from the mean. I'm going to show you that in a picture. So these are just tips that you can use when you're asked to describe and write in sentences. So here's the two teams, and I chose to show you this just so you can see what we are talking about as we're talking about the spread of data. These two teams, and what's really cool is that they have the same boundaries. There's 48 and then there's 62. The maximum and minimum are the same in both of these, and in both of these, the mean, the average is the same. So you can really see the difference. These are closer to the mean. They're also spread pretty evenly, and the spread is a lot different than Lena's team. Lena's team, they're kind of clustered over on the higher end and on the lower end, and there's not really that much around 55. So again, the MAD describes the spread of these data points. If it's a small MAD, that means they're closer together. If there's a larger MAD, it means it's farther away from the mean. Here's the summary in a nutshell. When you're talking about the MAD, you are describing the spread of the data. In red, when there's a small MAD, the MAD lets you know if the data values are clustered close together. So a little bit of repeat, but this is the summary at the end. The MAD, if it's a big MAD, a larger MAD, when you're comparing, lets you know if the data values are more spread out. They're closer to the extremes, if you look at that graph that we just looked at, the line plot for Lena, and therefore they're farther from the mean. That's the end of the notes. The only other thing we have is one that you can try. My last slide. Find the MAD. Here are the numbers. And then describe what the MAD represents. That was the first thing we talked about. We're not comparing two different sets. This is just find the MAD, and then what does that represent? Meaning, look at that box in your notes. That's the scripted answer that you could plug your MAD into. I will see you tomorrow. Have a good night.